Okay, here we go. Some review problems from 1.2 part 2. We start with 1/3 plus -1/6. And to add fractions, we need a common denominator. And one of the methods of finding the common denominator is to take multiples of the largest denominator. In this case, 6. Well, the first multiple, 6, is divisible by 3. So that is your least common denominator. So rewrite the 1/3 fraction in terms of 6 and then add these. Try this on your own. So we multiply the 1/3 by 2 and 2. And look what I did with the negative sign. I put it in the numerator of the 1/6. So it's -1/6. So that gives us 2/6 plus -1/6. We can combine numerators, 2 plus -1/6 to make 1/6 is our answer. Next problem is 5/7 minus -4/9. Now to do this problem, you're going to first want to rewrite that subtraction as 5/7 plus +4/9. Then you need a common denominator. And use one of the methods. Take multiples of 9 until you get a denominator that is divisible by 7. In this case, the least common denominator is 9 times 7, 63. Whenever the two denominators share no common factors, meaning there's no number that divides into both 7 and 9. Only 3 divides into 9 and only 7 divides into 7. When that's the case, the product of the denominators will always be the least common denominator. So 63. So rewrite these fractions and then rewrite them in terms of 60/3 and then add them. So we multiply the first fraction by 9 and 9, the second fraction by 7 and by 7. And when we're multiplying by 9/9, we're actually multiplying the fraction by 9/9 or 1. Okay, when we do that, we get these new fractions that we can add together, and we get 73 63rds or 1 and 10, not 1 and 10 63rds, but yeah, that's right, 1 and 10 63rds. I had it right. Okay, in our next problem, we're taking 5/12 minus 11/16. First thing we're going to have to do is find a common denominator, a least common denominator. Now you could take 12 times 16. That would give you a common denominator. But you can find a smaller one by taking multiples of 16. 1 times 16 is 16. 2 times 16 is 32, which does not divide 12. 3 times 16 is 48, and that is divisible by 12. So that's your least common denominator. So now you rewrite these fractions as 48ths and combine them. So we do this process of building each fraction. Multiply 5/12 by 4 and 4, or 4/4. Multiply the 11/16 by 3 and 3. So we get two new fractions of 20/48 minus 33/48. Now, we can rewrite that as 20/48 plus -33/48. Remember, subtracting a positive is the same as adding a negative. And when we do that, 20 plus -33 is -13/48, which we also can write as negative of the whole fraction 13/48. In this next problem, -5/22 plus -11/30, I'm going to show the method of using the least common multiples and the prime factorizations. This was that little trickier method that translates well to algebra to find the least common denominator. We could take multiples of 30 and we end up getting this big denominator, but we can use this other method using prime factorizations. And what we have to do is rewrite these numbers in prime factored form. We keep rewriting them till there's nothing but prime factors. Well, 22 is 2 times 11. Both 2 and 11 are prime. They cannot be broken down anymore. 30, however, is 2 times 15. But 15 can be broken down as 3 times 5. So now, using this method, our least common denominator has to contain all of the factors shown in the prime factorizations. There is a factor of 2 here. So we need a 2. We need an 11. In order to be divisible by 30, we also need a 3 and a 5. Now we only need 2 once. We don't need 2 squared, just one factor of 2. Now both of these denominators will divide into this product. And this multiplies out to, let's see, 15 times 2, 30 times 11 is 330. So our least common denominator is 330. So now rewrite those fractions with that new common denominator or least common denominator and then combine the two. So our first fraction, we have to multiply by 15. Now if we look at these prime factorizations, it has the factors 2 and 11, but it's missing the 3 and the 5, 15. The second fraction is only missing the 11 factor, so that's what we multiply by. So when we do that, we get negative 75 3/30 plus negative 121 3/30. And that adds up to negative 196 3/30, which then can be reduced to negative 98 1/65. In our next problem, we're going to do fraction division. Now the thing to always remember with fraction division is the first thing you do is invert and change to a multiply problem. So you change this into 2/5 times 500 200ths. Now you can cancel any numerator, any denominator, cancel out or divide out common factors. And you should do this because you don't want to multiply all these big numbers. First thing you can do is you can divide out 100 into the top and bottom of 500 200ths. So that reduces to 5/2. Then we can cancel out. 2 goes into 2 once and once. 5 goes into 5 once and once. Well, when we do all that canceling, all we're left with now is 1 times 1 over 1 times 1, which is 1. Everything canceled out after we inverted. Okay, here's a problem for you to try. 3/5 times 10/20 times 11/3. See if you can cancel wherever possible and then multiply the resulting or the fractions that are left after you cancel. So try this on your own. And in this problem, there's really only one way to cancel. Well, actually there's two. You could cancel the 5 and the 10. So there are a couple different ways you can cancel. This is the way I did it. I canceled factors of 10 to get 1/2. Then I canceled the 3's. that left me with 1/5 times 1/2 times 11 over 1, which is 1 times 1 times 11 over 5 times 2 times 1, making 11/10, or 1 1/10. And if you canceled the other way correctly, you should also get 11/10. Okay, next problem. We're going to multiply 2.002 times 5.005 longhand without a calculator. And this one's kind of tricky with all those decimal points, but we'll get through it. It's actually fairly straightforward. So maybe try this on your own and see what you get, and then come back and go through it with me. Okay, so to do this, we start with the 2 times 5 makes 0, 10. We carry a 1. Then 2 times 0. And to do this, pretend those decimal points are not here. So it's 2 times 10. There's 0 tens. 2 times hundreds. 0 hundreds. Then 2 times 5,000 makes 10,000. So we kind of pretend that decimal point's not there. So what we're really doing is the 2 times 5,005 to get 10,010. Now, for this next 0, when we multiply through, all of the entries would go 1 over. 0, 0, 0, 0. Then we have another 0 times all of these. Those entries would go over also 0, 0, 0, 0. And lastly, we do the 2, which if we ignore the decimal points is like 2,000 times 5,000. And we get 10 here. Now if I had some more zeros, that would be 10,000. So we have that 10 in the right spot. Then we have this 0 times 2, which would go right where the 1 is. This 0 times 2 goes right here. Then we have this 0 times 2 goes right there, that 0. Then we have the 2 times 5 is 10 right over here. Oh, and I just see that I put an extra 0 here. It should have been 001. I caught myself here. Because this 2 times 5,005 should be the same as this 2 times 5,005. We had 10010, which you get 10010, which we did. Now I got that fixed up. Now we add these columns. Now it's a matter of where to put the decimal point. And our top number has 3 places. Our bottom number has 3 places. 3 plus 3 makes 6 places. So add up the decimal places. That's one way of putting the decimal point. A better way is to just do an estimate where that decimal point should be. This is approximately equal to 2 times 5, which is 10. So we know the decimal point goes after the 10 here. So our answer is 10.02001. We don't need that trailing 0 at the end. We can leave that off. And yeah, and this is sort of a, I know it's, if you can do this multiply problem, you can do any, and I know this one's a bit difficult with all these placeholders. So if you mess that up, don't worry. The problem previous to this isn't so bad. Number 10 in the homework is more like what you should be able to do. Okay, in the next problem, we're going to divide decimals. 101.76 divided by 4.8. And what you want to do when you're dividing by a decimal is change it into a whole number by moving the decimal point on both your divisor and what's inside the dividing sign. That's called the dividend. So you change this problem into 1017.6 divided by 48. So once you do that, the decimal point will go straight up in your answer, and it becomes an easier problem to divide once you change that divisor into a whole number. So you start dividing. 48 into 101 goes twice. 2 times 48, 96. We subtract and carry down. We have a 5 and carry down the 7. 48 goes into the 57 one time. Subtract, get a 9, carry down that 6, and 48 goes into 96 and even 2 times. Now, and this is kind of unusual that it would divide in like that. If it didn't divide in an even number of times, you would just have to know where to round the answer off, or how many decimal places you wanted to keep. But in this case, it goes in an even number. So it's a terminating decimal answer of 21.2. Okay, next problem, and this will be the last problem. Divide 4.112 by 2.2 and round the answer to 2 decimal places. So do this long division and come back here and check to see what I got here. So pause the tape and try this. So the first thing to do is change it to 41.12 divided by 22. So if you haven't done that, make sure and do that before you start. So we do this division. 22 goes into 41 only one time. We subtract 41 minus 22 to get 19. Carry down a 1. Now we have to figure out 22. How many times does it go into 191? And that you have to do a little bit of figuring. You know that if you do 9 times 22, it's 198, which is too much. So 8 times 22 is 176. Subtract, get 15. Carry down the 2. How many 22s go into 152? Well, 6 of them do. 6 times 22 is 132. Subtract, get 20. And then we have to add a 0 to carry it down. And 9 22s go into 198. That gives us enough places to round it. We need that third place to round it up to 1.87. So that's our rounded answer. Okay, well that's it for this section. It's a lot of problems, a lot of stuff. And we'll see you in class.